Hello guys, welcome to your own clinical YouTube channel. So today we'll be discussing about alveolar ventilation. So here is a question. The elimination of carbon dioxide in a ventilated patient depends upon tidal volume, minute ventilation or alveolar ventilation. Which is most appropriate? So let us consider an example in which we are ventilating a patient. Let us consider it is volume control mode of ventilation. Okay, and we are ventilating the patient with a tidal volume of 500 ml with a respiratory rate of 12. Other parameters like FiO2, IE ratio, these things are there, but let us focus on the volume parameters over here. So from the 500 ml component, all the 500 ml or all the tidal volume component is not taking part in gaseous exchange. So it is divided into two parts. One is dead space volume and second is alveolar ventilation volume. So what is dead space? It is basically that component of tidal volume which is not taking part in gaseous exchange. So for an adult it is nearly equals to 150 ml. For pediatric population you can calculate it as 2 ml per kg body weight, right? Okay, so when we are ventilating a patient with a tidal volume of 500 and respiratory rate of 12 per minute, what is the minute ventilation? It is 6000 ml per minute, right? But when we calculate the alveolar minute ventilation is equals to respiratory rate into tidal volume minus dead space, which is equals to 4200 ml per minute. So the clinical significance of this concept lies where, let us consider we are ventilating a patient using a volume control mode of ventilation in which we are keeping minute ventilation same. Let us consider two scenarios, scenario 1 and scenario 2. We are keeping our minute ventilation same. Let us consider minute ventilation is 5000 ml. In first aspect, we are ventilating with a tidal volume of let us say 500 ml with respiratory rate of 10 per minute. So 500 into 10, the minute ventilation is 5000 ml. In second scenario, we just reduce the tidal volume to 250 and increase the respiratory rate to 20 per minute. Here also 250 into 20, the minute ventilation is the same. But what is the alveolar minute ventilation in both the scenario? So alveolar minute ventilation for first scenario is equals to respiratory rate into 500 minus dead space volume, which is equals to 3500 ml. But in second scenario, the alveolar minute ventilation, wait a second, alveolar minute ventilation is equals to 20 into 250 minus 150, which is the dead space, which comes to be 2000 ml. So in spite of being the same minute ventilation, there is a drastic difference in alveolar minute ventilation in two scenarios. Okay, so in these two scenarios, in spite of having the same minute ventilation, the gaseous exchange, particularly the carbon dioxide removal, will be different in situation 1 and situation 2. So keep in mind this concept while adjusting your ventilatory parameters. So Let me know in the comment section why neonates have higher respiratory rate as compared to adults. Keep learning. Thank you.